Dear students, welcome to this online class. In the previous section, we discussed about the combination of solids around us. And also we revised the formulas for finding the surface area and volumes of solid shapes. Hope that you all revised that. Today we will study about the areas of combination of solids.
Let us consider this tank. How do we find the surface area of this tanker? Suppose we want to paint this container. How much paint we would require to paint this tanker? How do we find this? We would need to know the surface area of the tanker. We know that the tanker or such a solid is in the combination of cylinder with a hemisphere at both ends. So total surface area of this tanker is the sum of the curved surface area of each of the individual parts. That is the curved surface area of two hemispheres and curved surface area of cylinder. So when you add these areas, we will get the total surface area of the container. So curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of hemisphere, that is equal to the total surface area of that solid. Consider this toy. Suppose you want to decorate this toy with a colored paper. How much colored paper we would require to cover this toy? For that, we would know the surface area of this toy. So surface area of this toy is equal to the sum of the curved surface area of cone plus curved surface area of hemisphere, because it's a combination of cone and a hemisphere. So curved surface area of cone plus curved surface area of hemisphere, that is equal to the total surface area of the toy. If you know the total surface area of the toy, that will be equal to the area of the paper we required. See this vessel. A vessel is in the form of a cylinder mounted on a hemisphere. A hollow cylinder mounted on a hollow hemisphere. So how do you find the surface area of this vessel? Here the surface area of this vessel is equal to the curved surface area of cylinder plus curved surface area of hemisphere. So we know how to find the curved surface area of a cylinder and how to find the curved surface area of a hemisphere. So if you know that both have the same radii, so if you know the radii, radius of the cylinder and that will be same as the radius of the hemisphere. So using that we are able to find the curved surface area of each one. Sum of these two areas will be equal to the total surface area of the vessel. Let us do some problems. A solid is in the form of a cylinder with hemispherical ends. The length of the solid is 108 cm and diameter of the hemispherical ends is 36 cm. Find the cost of polishing the surface of the solid at the rate of 7 paisa per centimeter square. So there will be the shape of that solid is cylindrical shape with the hemispherical ends. The total length of that solid is given for you 108 cm and the diameter of the hemispherical end is equal to 36 cm. We want to find the cost of polishing the surface of the solid. So to getting the total cost, first we want to know the area of the solid, that is the surface area of the solid, total surface area of the solid. Then only we are able to find the cost. So the total surface area of the solid means the curved surface area hemisphere and curved surface area of cylinder plus curved surface area of hemisphere. So this is the shape of that solid, a cylinder with the two hemispherical ends. So the total surface area of this solid is equal to curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of hemisphere. And the total length of the solid is given for you, that is 108 centimeter. And the diameter of the hemisphere, that is given for you 36 centimeter. So the diameter of this hemisphere and the diameter of the cylinder both are same. They have same base. So the radius of the hemisphere is equal to half of this diameter, that is equal to 18 centimeter. The radius of the hemisphere is the half of the diameter, that is 18 centimeter. So this length is also the radius of the hemisphere. And this is also the height, that is the height of that hemisphere, that is equal to the radius of the hemisphere. Because this is the center of the circle, and from the center to any point on the circle is known as the radius. So this is 18 centimeter, here also 18 centimeter. So total length is 108 centimeter. Then what will be the length of this cylinder? So this length, hemispherical length, we know it. Then what is the length of this cylinder? So you have to subtract these two lengths from the total length. So total length is 108 centimeter minus 18 centimeter minus 18 centimeter. That is, we want to subtract 108 minus 18 plus 18, 36. So 100 minus 18, 108 minus 36 is equal to 72. So the length of the or height of the cylinder is equal to 72 centimeter. So now we know the radius and height of the cylinder, and the same way we know the radius of the hemisphere. So we can able to find the curved surface area of these two shapes. So total surface area of the solid is equal to curved surface area of cylinder plus curved surface area of two hemispheres. Two hemispheres. So we know that the radius is equal to half of the diameter, that is equal to 18 centimeter, and height of the cylinder is equal to 72 centimeter, that is 108 minus 36, that is equal to 72 centimeter. Then, so the curved surface area of cylinder, total surface area is equal to curved surface area of cylinder, that is, we know that the curved surface area of cylinder is equal to 2 pi r h plus curved surface area of two hemispheres. Curved surface area hemisphere is equal to 2 pi r square. There are two hemispheres are there, so 2 into 2 pi r square. So 2 into both terms, you can see pi is a common thing. You can take it out or directly you can multiply it. Anyway you can do it. So 2 into 22 by 7 into radius, that is equal to 18 centimeter, into height of the cylinder is equal to 72 plus 2 into 2 pi r square, that is 4 pi r square. So 2 into 2, 4 into pi, that is 22 by 7 into radius r square, that is 18 into 18. So when you multiply these, and if there is any common factor you can cancel it, but here there is no common factors, and here also we cannot see any common factors. So multiply, you will get the denominator as 7, then multiply the product and add it. Both have the same denominator, so you can add the numerator and keep the denominator as it is. You will get the answer of total surface area of the hemisphere. Solid. That is equal to 57,024 by 7 plus, when you multiply this you will get 28,512 divided by 7. That is equal to 85,536 by 7. That is equal to 12,219.4. So the total surface area of the solid is equal to 12,219.4. We want to find the cost of polishing the surface of the solid. So total cost is equal to cost for polishing the surface. Cost is equal to surface area into cost of per centimeter square. So the total surface area is this much centimeter square. So 12,219.4 into 0.07, that is 7 paisa per centimeter square. Change it to rupees, then to multiply with 0.07, otherwise you can write 7 by 100. So that is equal to 855.36. So we require this much rupees to polishing the surface of the solid. See the next question. A toy is in the form of a cone surmounted on a hemisphere. The diameter of the base and the height of the cone are 6 cm and 4 cm respectively. Find the surface area of the toy. So the shape of the toy is in the form of a cone surmounted on a hemisphere. Surmounted means something to be placed on the top of another. So here a cone is standing on the top of hemisphere. So we can draw the figure, a hemisphere, and on the top of this hemisphere there will be a cone. Both have the same base. The radius of diameter which is given, the diameter of the base, that is 6 cm is given. Diameter is given 6 cm. And the height of the cone is given 4 cm respectively. Diameter is 6 cm, height is equal to 4 cm. So the radius will be equal to half of the diameter, that is 3 cm. We want to find the surface area of the toy. So the radius of the cone is 3 cm. Then what will be the radius of the hemisphere? Both have the same radius because both have same base. So the radius of the cone is equal to 3 cm. That is also same as the radius of the hemisphere. And what is the height of this hemisphere? That is also equal to the radius of the hemisphere. What is this radius? That is 3. So height of the cone is 4 cm. and this height of this hemisphere is equal to 3 centimeter. That will be equal to the radius. Now we want to find the surface area of this toy. So the surface area of this toy is equal to curved surface area of this cone plus curved surface area of hemisphere. Then you will get the total surface area of the toy. So first you have to write the radius. Radius of the solid is equal to 3 centimeter. Height of the cone is equal to 4 centimeter. We know that the curved surface area of cone is equal to pi r L, where L is a slant height. Here we know the height and radius. Then we want to find the slant height of the cone. So what is the slant height of the cone? We know that slant height is equal to square root of h square plus r square. Here x is equal to 4 centimeter. So it is 4 square plus radius is equal to 3 centimeter. That is equal to 3 square. So here square root of 16 plus 3 square is 9. That is equal to square root of 16 plus 9 is 25. That is equal to 5 centimeters. So the slant height of the cone is equal to 5 centimeter. Now we can find the curved surface area of cone. That is, we know it is pi r. We know the radius and we know the slant height. And what is the curved surface area of a hemisphere? That is equal to 2 pi r square. We know the radius, so we can find that area also. So the total surface area of the toy is equal to curved surface area of cone plus curved surface area of hemisphere. That is equal to, because when we separate this toy, when you split that toy, we will get two shapes. One is cone and another one is hemisphere. So the combination of cone and hemisphere all together, we are getting the shape of the toy. So that area of the toy is equal to curved surface area of cone plus curved surface area of hemisphere. We know that curved surface area of cone is pi r L plus curved surface area hemisphere is 2 pi r square. Both term pi is common, you can take it out. So it will be r L plus 2r square. Pi value we can substitute 22 by 7 or 3.14, anything you can use it. So 3.14 into radius, that is 3 centimeters. So 3 into slant height is 5 centimeter. 3 into 5 plus 2 into r square, 2 into 3 square. So that is equal to 3.14 into 3 5s are 15 plus 2 into 3 square, that is 2 into 9. 2 9s are 18. So 3.14 into 15 plus 18 is equal to 33. That is equal to 103.62. So the total surface area of the toy is equal to 103.62 centimeter square. You can see the next question. There are two cubes, each of volume 125 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. So two cubes joined end to end. Then if you join two cubes, you will get the cuboidal shape. So the volume of each cube is equal to 125 centimeter cube. So what we can find the length of the edge of each cube, because we know the volume of a cube is equal to a cube. So we can find the length A. And if we know the length of the cube, we know these two cubes are joining together. So the length of the cuboid will be sum of the sides of these two cubes. And breadth and height, there won't be any changes. So let's see the volume of cube. Volume of cube, we know that volume of cube is equal to a cube. So that is given for you 125 centimeter cube. Therefore, A is equal to, that is the length of the edge of each cube, that is equal to cube root of 125. Cube root of 125 is equal to 5 centimeter. 5 into 5 into 5 is 125. So length of the edge of each cube is equal to 5 centimeter. Such type of two cubes are joined end to end. So the dimensions of cuboid so formed. Dimensions of cuboid so formed are the length of the cuboid, that will be equal to 5 plus 5, that is 10 centimeter. And breadth, breadth is equal to 5 centimeter. Height is equal to 5 centimeter. We want to find the surface area of the resulting cuboid. So we know that the total surface area of a cuboid is equal to 2 into L into B plus B into H plus L into H. 2 into LB plus BH plus LH. So here we know the length, breadth and height of the cuboid. So we can find the total surface area of a cuboid. Total surface area of a cuboid, resulting cuboid, is equal to 2 into LB plus BH plus LH, that is equal to 2 into length into breadth, 10 into 5 plus B into H, breadth into height, 5 into 5 plus length into breadth, height, that is 10 into 5. 2 into 50 plus 25 plus 50, that is equal to 2 into 50 plus 50, 100. 100 plus 25, 125. That is equal to 125 into 2, that is equal to 5 2s are 10, 1 is carry over, 2 2s are 4 plus 1, 5, 1 2 is 2, 250 centimeter square. So area of the total surface area of the resulting cuboid is equal to 250 centimeter square. Let us see the next question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So, it's given for you, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So, on the top of hemisphere there will be a cylinder. A cylinder is standing on the top of hemisphere. Both are hollow cylinder and hollow hemisphere. Hollow hemisphere mounted by a hollow cylinder. So the diameter of the hemisphere is 14 centimeter. The cylinder and the hemisphere both have same base. So the diameter of the hemisphere is 14 centimeter. That will be same as the diameter of cylinder. And the total height of the vessel is 13 centimeter. We want to find the inner surface area of the vessel. So inner surface area, here there will be a cylinder and a hemisphere. The vessel will be in this shape. We want to find the inner surface area of the vessel. That means the inner surface of this cylinder plus inner surface area of the hemisphere. It's not a outer surface. We want to find the inner surface area. So inner surface area of cylinder is 2 pi RH, because we know the radius is given. We know the radius and we know the height. So it will be curved surface area of the cylinder. That is, we want to find only the inner curved surface area. And the same way, inner surface area of the hemisphere. So the inner surface area of or inner curved surface area of hemisphere plus inner curved surface area of cylinder. That is the total inner surface area of the vessel. So here it's given for you the diameter of the hemisphere is 14 centimeter. Then what is the radius of the hemisphere? That is equal to 7 centimeter. That radius is same as the radius of the cylinder. Cylinder and the hemisphere have the radius 7 centimeter. The next one is total height of the vessel. The total height of the vessel is 13 centimeter. We know that what is the height of this hemisphere? Height of the hemisphere is equal to 7 centimeter because that's a radius. So the height of the cylinder is equal to 13 minus 7. So that is equal to 6 centimeter. So height of the cylinder is equal to 6 centimeter and height of this hemisphere, that is the radius, that is equal to 7 centimeter. So 6 plus 7 total height is 13 centimeter. So we can write here the radius R is equal to 7 centimeter. That is the radius of the cylinder and the radius of the hemisphere. Then height of the cylinder. Height of the cylinder is equal to 6 centimeter. We know that is equal to 13 minus 7. We can write that also. 13 minus 7, that is equal to 6 centimeter. So the total surface area or inner surface area of the vessel. Inner surface area of the vessel is equal to curved surface area of inner curved surface area of cylinder plus inner curved surface area of hemisphere. That is equal to curved surface area of cylinder. You know, curved surface area of cylinder is 2 pi r h. If it is a outer curved or inner curved, the formula will be same. So inner curved surface area of cylinder is equal to 2 pi r h plus curved surface area hemisphere, that is 2 pi r square. Both have same radius and in both the term contains 2 pi. You can take 2 pi out. 2 and pi is common and r is also common, but you take it 2 pi out. Now RH plus R square. That is equal to 2 into, you can use 3.14 or 22 by 7 into radius into height. Radius is 7. 7 into height of the cylinder, that is equal to 6 centimeters. 7 into 6 plus R square, that is equal to 7 square, which is equal to 2 into 22 by 7 into 7 6 are 42. 42 plus 7 square is 49. So when you solve this, we will get the total surface area of the vessel, or inner surface area of the vessel, which is equal to 2 into 22, that is 44 by 7 into 42 plus 49, that is 91. So 44 into 91 by 7, that is equal to 572 centimeter square. In the previous section, we discussed about the tent. We see that the tent is the combination of cylinder and a conical cone. So let's see one question related to that. A tent is in the form of a right circular cylinder surmounted by a cone. The diameter of cylinder is 24 meter. The height of the cylindrical portion is 11 meter. While the vertex of the cone is 16 meter above the ground. Find the area of canvas required for the tent. So the tent is in the shape of a cylinder surmounted by a cone. That means the cone is standing on the top of a cylinder. And the height of the cylindrical portion is given for you, that is 11 meter. And the total length of the solid, or that tent is given, that is 60 meter. That means it's given like this. The height of the cylindrical portion is 11 meter, while the vertex of the cone is 16 meter above the ground. So this is the vertex of the cone. That vertex is 16 meter above the ground. This is the ground level. So above the ground it is 60 meter. That is the whole length of the tent. And it's given for you the length of the, or height of the cylindrical portion. We want to find the area of canvas required for the tent. A canvas means the cloth we required for preparing the tent. So to getting the area of that cloth or area of that canvas means that will be the area of the total curved surface area or total surface area of the tent. That means the area of curved surface area of cone plus curved surface area of cylinder. Note that the base of the tent will not be covered with the canvas. So only that curved portion of cylinder and curved portion of cone. So the total surface area of this tent is curved surface area of cone plus curved surface area of cylinder. And the diameter of the cylinder is given for you 24 centimeters. So the radius of the cylinder is half of that, that is 12 centimeter. Sorry, 12 meter. 12 meter. The radius of the cone and radius of the cylinder both are same because they have same base. And the height of the cylinder, that is given for you 11 meter. The total height of the tent is 16 meter. Cylindrical portion is 11 meter. Then what is the height of this cone? That is this, the height of the cone. That is equal to how much? 16 minus 11, that is 5 meter. Height of the cone is equal to 5 meter. So if you know the height and radius, we are able to find the slant height. If you know the slant height, you can find the curved surface area of cone, that is pi RL. And we know radius and height of the cylinder, so we are able to find the curved surface area of cylinder. So total surface area of the tent, that is equal to curved surface area of cone plus curved surface area of cylinder. So here radius is equal to 12 meter, height of cone is equal to 16 minus 11, that is 5 meter, height of cylinder that is equal to 11 meter. So total surface area of the tent is equal to curved surface area of cone, that is pi r l, plus curved surface area of cylinder, that is 2 pi r h. We want to find the slant height of the cone. Slant height of the cone is equal to, we can write here, L is equal to square root of h square plus r square, that is equal to square root of height of the cone is 5 meters. So 5 square plus radius 12 meters. So 12 square, that is equal to 25 plus 144, that is equal to square root of 169, that is equal to 13 meters. So the slant height of the cone is equal to 13 meter. Now we can substitute the value here. Pi value you can substitute 22 by 7 or 3.14. First, better you take that pi and r is common, you can take it out. Then what is inside? Slant height plus pi r is taken out, then 2 into h. So 22 by 7 into radius is equal to 12 into slant height 30 plus 2 into height of the cylinder. H is representing the height of the cylinder. So height of the cylinder is equal to 11 meter. Height of cylinder, that is 11. So 2 into 11. So it will be 22 by 7 into 12 into 13 plus 2 into 11 is 22. 13 plus 22, that is 35. So when you multiply these all, you will get the total surface area of the tent. That will be equal to the area of canvas required for making that tent. So dear children, you have to practice these questions. So how many questions we discussed today? You have to practice and then you should write it in the notebook. And the same way you have to revise that formulas for finding surface areas and volumes of solid shapes. And practice, write and study when you are practicing these questions. Your calculations, 2 or 3 times you have to write and study the whole calculation, multiplication, division and what all things, that you should write it in the working column neatly. And the same way you have worksheet. Today's your worksheet is exercise 13.1, question number 1, 3, 6 and 7. So you have to do that worksheet, practice it and write it in the notebook. Keep your notebook very neatly and study properly. Thank you.